Hello everyone. In this video, I'll explain limit supremum and limit infimum of an infinite sequence, which is also called as limit superior and limit inferior. So, if you consider any sequence an, then supremum of that sequence an, it is nothing but it is the number which is greater than or equal to each term of given sequence. That is called as supremum of the given sequence an. For example, if I consider this sequence an, whose first two terms are 2 and minus 2, then remaining terms are given as minus 1, 1, minus 1, 1 and so on. So the sequence general term can also be written as a1 is 2, a2 is minus 2, then an is minus 1 to the power n is greater than or equal to 3. Now, when you consider this sequence, if you want to find the supremum of this sequence, it is the number which is greater than or equal to every element of every member of this sequence. So, if you want to find supremum of an, which is equal to 2, because 2 is equal to 2, 2 is greater than minus 2, 2 is greater than minus 1, then 2 is greater than 1 and so on. Therefore, supremum of an equal to 2. So, when we have the concept of supremum, why we need limit supremum? What is the meaning of limit supremum? Limit supremum that gives you eventual and extreme bounds on given sequence. So, what is this eventual and extreme bounds? We are finding the supremum of the sequence as n tends to infinity. That means as we move towards the larger and larger values of n, only at those particular region of the sequence we want to find out what is the largest value. That is, what if we want to know what the greatest number as we move towards infinitely many members of the sequence? See, look here, graphically, the points of the sequence can be represented as follow, where this horizontal line is natural numbers because domain of the sequence is n, and this vertical line is the real line because the range or codomain of the sequence is a set of all real. So first point as n equal to 1, first term of the sequence is 2, second term is minus 2, then third term is minus 1, fourth term is 1, fifth term is minus 1, sixth term is 1 and so on. As n tends to infinity, what is the maximum value? So, for that, we have to move towards the tail of the sequence. Whenever you consider any sequence, it has two parts, head and tail. You consider any member of the sequence, then the finitely many terms lies towards the left of the sequence, that is called its head, and infinitely many members lie towards the right of the sequence, that is called as a tail of the sequence. So, in the case of limit supremum, we want to find out how large can the tails of the sequence. In the case of limit infimum, how small can the tails of the sequence eventually be. So, it gives you the largest accumulation value and it gives you the smallest accumulation value. So, therefore, in the case of limit supremum, we have to ignore the terms, finitely many terms, which lie at the head of the sequence, and we have to concentrate on the terms which are towards the tail of the sequence. So, as n tend to infinity, what is the supremum of the given sequence? That is called as limit supremum. So, in this case, if you want to find out limit supremum, so you have to ignore the first terms in the beginning. So, first, so for that you have to form a1 equal to supremum of the first terms 2 minus 2 minus 1, 1 minus 1, 1 and so on, which is the largest value among this, that is 2. then a2 equal to supremum of, leave the first term. So when you leave the first term, 2 minus 2 minus 1 1. So here, which is the largest value? 1 is the largest value. So minus 2 minus 1 1 minus 1, so on. 1 is the largest value. So a3 equal to supremum of, leave the first term, leave the second term. Now in these, so you will get minus 1, 1, minus 1, 1 and so on. So 1 is the largest value. So if you continue like this, you will get a new sequence A1, A2, A3. These are all supremums. Now you get a sequence of supremums A1, A2, A3 and so on. Now you have to find out limit of this sequence. That gives you limit supremum. So limit supremum of an is nothing but as n tends to infinity, which is denoted as limit superior of an as n tends to infinity, which is equal to limit as n tends to infinity a1, a2, a3 and so on. You have to find out the limit of this sequence. This is monotonically decreasing sequence because initially we got the value 2, then it is 1, then it is 1. There may be constant sequence also, but in general, whenever you have any sequence which is not constant sequence, so in that case you will get a monotonically decreasing sequence. So you have to find the limit of that sequence, which gives you limit suprema. So limit n tends to infinity. How will you write the general term of this sequence? That is, this is 2, 1, 1, 1 and so on. So limiting value of this sequence, though it has 2 here, but when you go towards infinity, it is having 1. Therefore, the limit supremum of this sequence is 1. Whereas supremum of this given sequence is 2, but limit supremum is 1. One more way to write this is equal to infimum of supremum of an, where n is greater than or equal to k. Supremum of an, that is what? A1, then A2, then A3. So you have to find here infimum. First you have to get the supremum and then you have to find infimum, not supremum again. That is because initially largest value, then you will get second smallest, then another smaller value, smaller value, like this, because it is monotonically decreasing sequence. That's why you are finding finally it's infimum, not supremum again. If you go once again with the supremum, what happens? It gives you the largest value, which is towards the head of the sequence. We are not concentrating at the head of the sequence, we are concentrating at the tail of the sequence. That's why it is called as eventual and extreme bounds on the given sequence. Then why you need limit supremum and limit infimum? This will help you to check the convergence of the sequence. That means if limit supremum of a sequence equal to limit infimum of a sequence, then such sequence is convergent. This supremum and infimum of any sequence just gives you bounds on the sequence. But this limit supremum and limit infimum of any sequence gives you eventual bounds, which will help you to find out the convergence and divergence of a sequence. If both limit supremum and limit infimum coincide, then such a sequence is convergent. Now, how to find limit superior and limit inferior of a given sequence? There are two cases. The first case is unbounded sequences and the second case is bounded sequences. So, in the first case, unbounded sequences, if the given sequence is not bounded above, then in that case limit supremum of that sequence equal to plus infinity. If the given sequence is not bounded below, then in that case limit infimum of that sequence is equal to minus infinity. Therefore, First, you need to check whether the given sequence is bounded above when you are finding limit supremum. You have to check is it bounded below when you are finding limit infimum. So, if it is a bounded sequence, then limit supremum and limit infimum is obtained by finding the limit points of that given sequence. You have to find out all possible limit points of the given sequence. Then maximum of that limit points is limit supremum and minimum of that limit points, set of limit points is called as limit infimum. Or else another way, you have to find out all possible subsequences associated with that given sequence. Then you have to find out the limits of those subsequences, subsequential limits. Then the highest value of that subsequential limits is limit supremum and the lowest value of subsequential limits is limit infimum. Let us understand this by considering few example problems. Consider example minus 1 to the power n. In the term of a sequence is minus 1 to the power n. So when you expand, you will get minus 1, 1, minus 1, 1 and so on. So this is the given sequence. You can see that clearly this sequence is a bounded sequence. So whenever you have a bounded sequence, to find the limit supremum and limit infimum of this bounded sequence, you have to find out set of limit points of the sequence. Limit points of the sequence, how many limit points are there for this sequence? So one possibility, limit as n tends to infinity, because when n is odd, n is even, two different values, minus 1 to the power 2n. So which gives you limit as n tends to infinity, minus 1 to the power 2n is 1, which is equal to 1. This is one limit point. And another is limit n tends to infinity, minus 1 power 2n plus 1. That is limit n tends to infinity. This is minus 1, which is equal to minus 1. These are the two limit points. So maximum of these two limit points is limit supremum. Therefore, limit supremum of an equal to 1 and limit infimum of an equal to minus 1. Here limit supremum not equal to limit infimum. Hence the sequence is not convergent. That is the way of checking the convergence of a sequence using limit supremum and limit infimum. Now, one more way is getting the subsequences of the given sequence. There are two subsequences. One is 1, 1, 1 and so on. Another is minus 1, minus 1, minus 1 and so on. Now find the limits of these subsequences, where this subsequence will converge to as n tends to infinity. That goes to 1. As n tends to infinity, this subsequence goes to minus 1. Therefore, you got subsequential limits. There are two subsequential limits. The maximum is limit supremum and the minimum of this is limit infimum. Consider one more example. You have to find out limit supremum and limits infimum of this sequence whose nth term is given here. Clearly, this is a bounded sequence. So, when you have a bounded sequence, you have to get the limit points of this sequence. So, limit as n tends to infinity. Whenever you have minus 1 to the power any value, always even or two possibilities you have to check. So, minus 1 power 2n into 1 plus 1 by 2n. So, which gives you this is positive. As n tends to infinity, 1 by infinity 0, which gives you 1. Similarly, limit n tends to infinity, minus 1 power 2n plus 1 into 1 plus 1 by 2n plus 1. This gives you minus 1. Therefore, here limit points are 1 and minus 1. Limit supremum is equal to 1. Limit infimum of this sequence equal to minus 1. Largest among the limit points is limit supremum and smallest among the limit points is limit infimum. You can solve this using the concept of subsequences as well. So when you expand this sequence, you will get the terms of the sequence. Now you have to form the subsequences of this sequence. One is minus 2, minus 4 by 3, minus 6 by 5 and so on. Another subsequence is 3 by 2, 5 by 4, 7 by 6 and so on. Now you have to find out the limit of this sequence. Minus 2, minus 4 by 3, so it goes towards minus 1. Then 3 by 2, 5 by 4, 7 by 6, so it goes towards plus 1. This was 1.5, then it decreases 1.25, then 1.1, so it is going towards 1. So subsequential limits are minus 1 and 1. Maximum of subsequential limits is 1. Minimum is minus 1. Therefore limit supremum, and this is limit infinite. Consider another example. Here nth term of this sequence is n to the power sin n pi by 2. Let us write the terms of the sequence one by one. 1 to the power sin pi by 2 is 1. Next n equal to 2. 2 to the power sin 2 pi by 2 is nothing but sin 2 pi. Sin 2 pi by 2 is nothing but sin pi. Sin of any pi is 0. So 2 to the power 0, it gives you the value 1. Then sin n equal to 3. So n equal to 3, 3 to the power sin 3 pi by 2. 3 pi by 2 value is minus 1. So 3 to the power minus 1, which is 1 by 3. Next 4 to the power 4 to the power sin of 4 pi by 2 is nothing but 4 to the power sin 2 pi. Sin of any pi is 0, so 4 power 0 is 1. Then 5 to the power sin of 5 pi by 2. 5 pi by 2 is 1. Sin of 5 pi by 2 value is 1, therefore you will get 5. Then again 6 to the power, that is 1. Then 7 to the power sin 7 pi by 2, which gives you 1 by 7, and so on. Therefore, now instead of finding limit points of this sequence, I have written the terms of the sequence. Now, better you can go with the subsequences associated with this sequence. That is easier compared to finding the limits of the sequence. So, here the subsequences are, one is 1, this repeats 1, 1, then that repeats 1, comma 1, comma 1, and so on. So, another subsequence is 1 by 3, comma 1 by 7, comma 1 by 11, comma so on. One more subsequence you can find, that is 1, comma 5, comma 9, comma and so on. These are the three subsequences associated with the given sequence. You have to find out the subsequential limits. As n tends to infinity, this sequence tends to 1. As n tends to infinity, this sequence tends to 0. As n tends to infinity, this sequence tends to infinity. 1, 5, 9, 13 and so on means it goes to infinity. Now, therefore, subsequential limits are 1, 0, infinity, which is the maximum among these infinity. Therefore, limit supremum of this sequence equal to infinity and limit infimum of this sequence equal to 0. See one more sequence with nth term is given like this. When n is odd, n by n plus 1. When n is even, 1 by n plus 1. Therefore, n is odd means you have to find out either the subsequences or the limit points of the given sequence. So, when n is odd, so it is 2n plus 1 divided by 2n plus 1 plus 1, that is 2n plus 2, which is equal to limit as n tends to infinity, 2n common 1 plus 1 by 2n divided by 2n outside 1 plus 2 by 2n. So this cancels. As n tends to infinity, this gives you the value 1. Similarly, when n is even, limit as n tends to infinity 1 by 2n plus 1. So as n tends to infinity, 1 by infinity, which is equal to 0. These are the limit points of the given sequence 0 and 1. Therefore, limit supremum of this sequence is maximum value 1. Limit infimum of this sequence is minimum value, which is 0. See these two sequences here. When you write the terms of the sequence, you will get 1, 1 by 2, 1 by 3, 1 by 4 and so on. I will directly find the limit of the sequence as n tends to infinity, which is 1 by infinity, that is equal to 0. There is only one limit point for this sequence. Therefore, limit supremum, maximum of that value is also 0. Minimum same. Limit infimum of an is also equal to 0. So in this case, limit supremum equal to limit infimum. Hence, it is a convergent sequence. Or else another way is writing A1, writing the supremum of all these terms. Then A2, leave the first term, write the supremum 1 by 2. Then leave the first two terms, write the supremum 1 by 3 and so on. Then finding the infimum of that set also gives you the value of limit supremum as 0. See in this sequence, now there are two cases. One is when n is even and another is 1 and n is odd. So when n is even, limit n tends to infinity. 1 plus minus 1 power 2n is nothing but 1 by 2n, which gives you 2 by 2n, which is limit n tends to infinity 1 by n, which is 0. When n is odd, we will get limit n tends to infinity 1 minus 1 by 2n plus 1. So whatever by this value, 1 minus 1 gives you 0. So in this case, the limit point is only one point, that is 0. Therefore, the maximum limit supremum of this sequence is 0 and limit infimum of this sequence is also 0. Given sequence with the nth term n. So when you write all terms of the sequence, you'll get 1, 2, 3, 4 and so on. So here you can see the sequence is not bounded above. Not bounded above. Therefore, as n tends to infinity, what is the limit supremum of that sequence? That also tends to infinity. Limit of an as n tends to infinity. That is limit supremum of an as n tends to infinity equal to plus infinity, as this sequence is not bounded above. But this sequence is bounded below. Now to find the limit infimum of this sequence, so first we need a1. a1 is infimum of 1, 2, 3, 4 and so on, which is the smallest element 1. a2 is infimum of 2, 3, 4 and so on. Ignore the first term. Then 2. a3 is infimum of 3, 4 and so on, which is equal to 3. So when you continue like this, you will get a new sequence 1, 2, 3, 4 and so on. You have to find out the limit of this sequence. Limit as n tends to infinity, which is equal to, as it goes on, as n tends to infinity, the limiting value is also infinity. Therefore, in this case, limit infimum of this sequence an is also plus infinity. Though it is bounded below, its limit infimum is plus infinity. So if limit supremum and limit infimum both are equal to plus infinity or minus infinity, in that case the given sequence is divergent. Here the given sequence is divergent. See the second example. So minus 1, minus 2, minus 3, minus 4 and so on. Now this sequence is not bounded below. So whenever a sequence is not bounded below, therefore its limit infimum equal to minus infinity. Keep it in mind. Now you have to find out limit supremum. To find the limit supremum, it is bounded above. So therefore a1 equal to minus 1, minus 2 and so on, which is the largest term, which is minus 1. a2 equal to, leave the first term, minus 2, minus 3 and so on. Largest term is minus 2. Then a3 equal to again minus 3 and so on. So you will get a sequence minus 2, minus 3 and so on. So here you are finding the supremum, here also supremum. Then finally we need infimum. The smallest term among these terms is, there is no smallest. As you go towards infinity, this terms also go towards infinity. Therefore, it is a minus infinity. So, in this case, limit supremum is minus infinity as well as limit infimum is minus infinity. If both are equal to minus infinity, then the given sequence is divergent. This is also a divergent sequence. Therefore, in the case of unbounded sequences, when the sequence is not bounded above, then in that case limit supremum equal to plus infinity. If the sequence is not bounded below, then limit infimum of that sequence equal to minus infinity. This is in unbounded cases. And in the case of bounded sequence, then you will have two methods. Either you can find out subsequential limits or else directly limit points of the sequence. Subsequential limits means both same almost, but here we are listing the subsequences and finding the subsequential limits. In this case, directly we are using the given nth term of the sequence and finding the limit points of that sequence, and maximum of these values is limit supremum of the sequence, minimum of these values is limit infimum of the sequence. Therefore, supremum of any sequence gives you the bounds on the sequence where each and every term is considered, whereas limit supremum or limit infimum gives you eventual and extreme bounds on the sequence. That is, when you move towards the tail of the sequence, what is the supremum? That is called as limit supremum. When you move towards the tail of the sequence, what is infimum? That is called as limit infimum. That is the major difference between supremum, limit supremum, and infimum, limit infimum. Limit supremum and limit infimum will contribute to find the convergence of the sequence. If both are same, then it is convergent, and it is having finite value means they are convergent. If both are equal to plus infinity or minus infinity, then that sequence is divergent. So, limit supremum and limit infimum will help you in finding the convergence of the sequence, whereas supremum and infimum will give you the bounds on the sequence. I hope you understood the concept. Thank you for watching.